Hey, welcome back to the channel. Good to see you again. Hope you're all well. Thanks for joining. Today on the bench I have a Marantz. This is an integrated amplifier, model 1122 DC. Console stereo amplifier. It's very nice condition, very smart looking. It's got some nice controls. It has an input for microphone and two microphone inputs left and right. Switch the microphone. Two phono stages. You have to select between two different turntables, one tuner, one auxiliary, and two tape loops. You can monitor your tape from here or from here, because this is your tape monitor. Interesting. Bass and treble, mid, tone controls, and these are the sliders. Knobs don't look like they're put on right. Anyways, mode switch for reverse stereo, left plus right, mono, left channel or right channel listening, volume control, power button, and two sets of speakers, loudness, low and high filters, tone defeat button, which is nice, and a balance control that's broken off, so we'll have to deal with that. So this is in for full service, and we're going to give it that. So let's have a look at the back quick. Alrighty, so we have our two phono inputs, 1 and 2, tape monitor 1, tape monitor 2, our tuner auxiliary, preamp output, main amp input. That's good, but there's no jumpers. It has AC coupling here, DC coupling, so I guess you can select between the two. I don't know if it's already pre-connected inside or if you need jumpers. That's unusual. I have to read up on that. And two speaker outputs, 4 courtesy outlets, 2 switched, 2 unswitched. And we have a 4 amp fuse. So let's look inside. Alright, here we go for the first reveal. The lid looks pretty clean. What do we have inside? A big massive power transformer in the center. Power supply board down here. And power amplifiers. 2 of them. Looks like they share one big large board. This here looks like input switching and phono stage. And then up in front here we have all of our tone circuits. So this will be an interesting subject to work on. I don't get to work on too many Marantzes. I think the owners hold them very dear to their heart and they don't like sending them out. Yeah, I don't work on too many Marantzes. I have the odd one here and there. Quite a bit of dust, so I'm gonna take this. You can see a lot of dust inside the power amplifier board here and on the power supply. So I'm going to take this outside and give it a good blast with compressed air and clean up some of this. It's not too bad, but we'll get rid of whatever dust we can first. No removable bottom on this Marantz, but they do have the ability to tilt the front and back panel out. You see here by these screws. You remove these screws and a few screws along the bottom and loosen this one, and it should just fold forward, and this one should fold back. So pretty much that's what you're limited to. Not very difficult to service anyways. The boards are easy to get in and out. It looks like there's modular connectors, and everything looks like it could be just disassembled easily. Alright, first up is the phono amplifier input switching board. I'm really struggling to find a reason to change these capacitors. They're testing perfectly. They are the orange drops, but I don't see any problems with these at all whatsoever. Aside from the circuit glue they're using, I'll have to remove some circuit glue here. I don't think it's affecting the circuits right now, but I'm going to make sure it's all gone. These caps are good. These ones are all good. I did replace this one. From this monstrosity. They had this tacked off board, so I removed this and put one on board. That's the only upgrade I made to this board, and I've gone through. The switches were heavily oxidized, so I opted to remove them because there's really no way to get in here and clean from the top, so I wanted to get in the underside, and I got better access from underneath. I don't want to disassemble this because they have some funny crimps here, and I don't want to snap one of those. I could disassemble this by crushing these together and pulling it all apart. But then you risk mixing these up, and you risk you know, damaging things inside. So I'm just going to leave it like this and clean from below. I think this is it's good for this. Like I said, heavy oxidation. I got to go in there and clean this all up. Same with this switch. This one I did already. I actually removed the front plate and re-lubricated the balls and cleaned the switch itself. So this one's good to go. This one I still have more work to do. And these caps I think are going to stay. This is a phono stage. I might feel a lot different when I get to different parts of the amplifier, but for right now I'm going to just leave this. If it's working fine and the caps are measuring great, I'm just going to leave it. So that's that. And this is the input board on the back. And really not much to do here. I'm going to do some cleaning and just some cleaning. Make sure all these are clean, and I'll clean the back and then put that back in too. So I've got some kind of problem with this board here. You can see this. I don't know if you can see the spots on this printed circuit board. Now this board faces this direction. This side is up in the cabinet, in the chassis, and it was all covered with dust. And I think some of that dust was corrosive for some reason, because a lot of the solder mask is eaten through with these. See these dots? Wherever I scrape, the solder mask is just falling off and exposing copper underneath that's being corroded. So some corrosion happening here. I think what I want to do is I want to put a coating on this. I have this stuff here. This is MG Chemicals number 422 conformal coating. I'm going to try this out on this board. I'm just going to coat this. I'm going to try and clean it really well, get all the rosin flux off as much as I can, and then I'm going to take it outside and I'm going to coat it with this coating and see if we can protect this from corroding any further, because we don't want to see any corrosion on these traces. It's all over. Everything's spotted everywhere you look. So yeah, even up here, you don't want the corrosion to advance any farther. So I'm going to clean this up. Alright, here it is. After I coated it, I let it sit in the sun for about a half hour, and it nicely dried up. It's got a nice coating on it. So main thing to know about this is if you want to do this coating, you have to make sure you do all your circuit board repairs and replacements before, because it makes soldering difficult. Not impossible, but it just makes it a little more difficult. And this stuff turned out pretty good. I think it's supposed to have a UV indicator in it, so let's try this out. Oh yeah, you can see it's coated. All of the joints are coated. So a little bit in that corner I missed. No, it's pretty good. A few bubbles here and there. But I think that's going to stop the corrosion, so that's good. Let's finish this and put it back in. I think I'm done pretty much. I soldered the switches back. I'm not changing these caps. Actually, I'm going to lay some of these down. Alright, onto the tone amplifier or tone board, whatever you want to call it. It comes out as a unit, pretty easy. You have to remove 16 screws from the switches and the sliders, and 2 nuts from the rotary switches, volume control, and it just pops right out. And 1 connector. Where does that connect? This one here is a 5-pin. And yeah, it just pops right out. So I removed the solder and removed this switch already, because I'm going to do cleaning on this. I think this is the stereo forward reverse switch. So we're going to fix that up. We're going to clean that. The main thing on this one is this balance is broken. Now, the owner works at a place, or he owns a shop where he has access to a water jet cutter, and he cut me out some blanks here. And he says if they're useful to me, I could use them. He also supplied me with a fresh knob that he bought off eBay. He probably paid too much. But this here, he provided a bunch of these blanks. And the idea is to, he was thinking epoxy this on to the original. And that would provide a good connection there, but I don't know about that. I think I could spot weld this on. I could put two or three spot welds on here, and that would never come off again. Another thing I could do is I could just disassemble one of these pots and send him the original, and he could just recreate a replica, and then I can just change this out. I think I might do that. Let's. I already desoldered this one, so let's pull it out, and we can open this up and see how. It's kind of a special pot because it has two wipers and two tracks. There's a point here where you have, like for example, this side you have your resistance from this to here, and then from here it's 0 ohms. And then the opposite on this side, you have your resistance from here to here, and then you have your 0 ohms, and then to your balance pot. But we can, these are kind of hard to find. I thought maybe if it was just a regular linear pot, I could just buy another one, but because you can buy these, but not the fancy ones like this. Okay, so let's try this. We should mark some of this before I pull it all apart so I don't get it all mixed up. Alright, put a mark here and here, and that should. Why is it holding? I don't have them spread enough. Okay, I should do it. Okay. Yeah, see, like it's got resistance here and then 0 ohms here. And then these two tracks are your are 0 ohms all the way. And then your resistance is here and here. So we'll put this aside. I don't want to damage that for sure. I don't want to damage this. Oops. Okay, so there was a ball and a spring in here. I'll have to hunt that down. Mainly looking at this. What holds this in? I think it's just pressed in place. Or it's molded. Be careful we don't bend these. Okay, that goes like that. Yeah, this here is definitely injection molded around this piece, so I don't think that's going to come apart. It's not loose and it's not going to pull out. Beginning to think the spot welding would be the best idea. Spot weld a new one on, and we'll see if we can do that. Problem is, it's a little thick. These ones are a bit thinner. quite the same dimensions. Where's our... It's not a bad fit. It's a pretty good fit actually. It's the right thickness. It's got some good grip. Oh. Yeah, I think the way forward is to spot weld this on. And then that will permanently bond that piece to there, and then we can, we're going to have to bend this a little bit so it fits through the slot. But once we put it all together, you won't even know. Okay, so let's do that. Alright, so before I weld it, I make sure I put these two pieces back on, otherwise you'll never get them on after. And I want to wrap this in some masking tape just to protect these contacts. They're very fragile. So I'm going to go just going to wrap this. And then I cut another one. Just to protect that. Okay, now I think I'm ready. So it doesn't matter which one I use here. I think they're a little too, well, I have to see. I might cut a little bit off here. I got a shear right here. I'll just do that right now. Okay, I cut probably 2 millimeters off just to give us some clearance from the body of the potentiometer. And we can go get that lined up and spot weld that. Let's go do it. And I did find the spring and ball, so they're here. So I haven't used this in a while. I'm just going to clean up some of the surface. Just very lightly clean up the contacts on this. Now, let's see if we can get this aligned properly. One of the worries I have is this puts out a lot of heat, and the heat will travel from here into the plastic and destroy the bond and melt the crap out of it. So let's clamp this in place. I think that's aligned well. Okay, let's try this. This thing pops the breaker every time I use it, so. Okay, here we go. Okay. Didn't want that going on for very long. That's a good spot weld there. Actually, it didn't get hot. But it does want to burn through, as you can see, but it is welded. Let's put two more. Let's put one up here. Probably should have started here first. Put one right here. Okay. Yo. And that one destroyed the base metal. I'm going. This metal is more tougher than this. This is some kind of pot metal. So I got to go easy on the trigger here. Got one more to do. And we're going to make it quick. That's good. I think that's good. And clean this up. It didn't get hot. Okay, perfect. We're back at the bench. I think that worked great. This must be some kind of stainless steel he supplied. I'm not sure. This stuff has definitely got a lower temperature and just kind of melted out. But this stuff held together, and that is secure. That's not coming off. It will break off the plastic before anything else. So what I need to do now is dress this up with a Dremel. I need to clean up all this slag and blow it out. And this here can actually come off. It's not providing any value. Just take that right off. But yeah, that is a great result, I think. I wonder if this is aluminum. I don't know. So I may need to bend this to align the button with the center of the slot. So yeah, this is going to work. So like I said, I'm going to dress this up with a Dremel, get a grinding stone, and then I'll submerge the whole thing in a ultrasonic, clean it all up, and then we'll reassemble. I might even actually trim some of the sides off here, a little too wide right here. This doesn't matter. Excellent. Alright, let's finish this up. I took a Dremel and cleaned off all the surfaces so it's nice, smooth, there's no more splatter. Just gonna clean this off. And we can get this put back together again. Those still look good. Okay. Now let's clean this up. We have to get rid of the old grease. All right. Okay. Now let's re-grease this. Let's see, where's my grease? Okay, so I'm going to use this is Chinese synthetic grease. It's good general purpose. Don't need that much. About that much. Now this is just going on the mechanical slide. This isn't going to go on the contacts. This is just going to be for the body of the slider. I'll lubricate this side. I don't think you want to get this stuff on the electrical contacts because it probably wouldn't work as a good, probably too much. Okay. So our ball is on this side. This is where the detent is. So we're going to put it together this side. And we have our thing in place, which was important. This track slider thing here is it's like a plastic. So we'll put that in there. Let's get our ball and spring. Get our spring in here. And the ball. Put this back in. Okay, you should be able to feel it. Feel the ball on that. Very good. Everything's good. Put that down. Now, this thing. Got some cleaning to do. Okay, I'm just going to use Neutral 401B. This has a lubricant in it, but I'm just going to use it as a cleaner. Get some on it. We're going to clean these tracks. This first one here is a silver track, and this third one is a silver track as well. We want to clean these up. Get the oxidation off for sure. And we want to clean the oxidation off of these. See, this is what spraying this stuff into the control will not remove this oxide. This is why I advocate for taking it apart and cleaning it. Let's do one more application. That one came back pretty black. Okay. Okay, looks like we got most of it the first time around, but we're still picking up a little bit of black. So these tracks here are silver plated. Those are the ones that are going to oxidize and cause your scratchiness. So you want to remove as much of that black as you can. And these are your resistive tracks. You don't want to overly work these because you'll start removing carbon, and that's not what you want. You just want to remove the dirt. Okay, that's perfect. So what we'll do is we're going to use deoxit fader on this one. Just put down a very fine, and then this one. And we're going to use deoxit D100L for the other two. This probably isn't going to stay where you put it, so once we assemble it and we start working the slider, it's going to distribute. Okay, we got some trash in here. Okay, where's our alignment marks? Here we are. It says trash. What is this? Okay. Put this together. Now you can take an ohm meter and do your ohm checks, make sure that it is good. If your contacts are bent in too much, they might not make contact with the tracks, so you might have to take a knife or a screwdriver and very carefully bend those out so that they protrude more. But I think this is good. Has a good feel to it. Okay, let's fold this over and close this up. Okay, I'll do all 8 of these. Now you're going to notice this is still loose. Just go like this and squeeze these together, and that will clamp the board in. Okay, that's no longer moving around. Let's finish these off, flatten them out. Okay, good. This is ready to go back in. Okay, this one's ready to go back in, but I'm also thinking I'm going to pull these other 3 out and do the same treatment. Take them apart, clean off the black oxides, and put them back together again. These deserve to be scratch free, and they're probably oxidized just as bad as this one was. So these switches are unique, kind of interesting. Have a unique mechanism on them for latching. It's complicated. It's easy to break, but it also looks easy to clean too. You can spray right in there, and we'll do that. And I'm also looking at these transistors. These are 2SA, where are they? 2SA 750s, and they are on my list for having noisy, for getting noisy. And they can be replaced with KSA 992s, but I think these are complementary pairs, so I might have to replace these in pairs just so that, you know, they're complementary and they still work together properly, because the other transistor is a 2SC 1222, and that's not on my list. So I wouldn't want to change one of these to find out that we no longer have a complementary pair in there and it's doing it's not working at its best. I'm also thinking I'm just going to recap the few caps that are on here. We got some 1 microfarads. These can go for film caps. I got 4.7s here. And replace those with audio grade. 3.3s here. What else? 100 microfarad, and then the power supply cap. We'll just replace them all. Clean the switches up, and then this tone board will be done. I need remove some of this glue, and we'll clean this up and get this back in shape. Haven't seen any cracked solder joints yet, but I also haven't looked at the power supply or the power amplifier, so that's where I expect to find them. So next, remove these 3 and clean them. I'll do that off camera. Alright, so everything on this board is done. I removed these 4 sliders and treated them, cleaned them, treated them. Disassembled the switch, cleaned and treated this, treated the pot, treated these 4 switches, all new caps, 4 new transistors, PMPs, and I cleaned the board. There's a little bit of corrosion right here in this spot. There was a big blob of circuit glue here, but I scraped it off. Hopefully that should be okay. I might treat this area just with a little bit of coating just to keep oxygen off of it. I didn't get all of the glue off, but it's all there, and the rest of it is very straightforward and not much to say. I'll tack this wire down so it's not flopping, and that's the end of that one. We're done. Now on to the power amplifier. This is very easy to remove. You had to remove 4 screws, 3 from the bottom and 1 from the top. There was a capacitor that was grounded here, and then there's 1, 2, 3 connectors, and then the whole board just falls out, and there's a lot going on here. Got 2 whole amplifiers, and I'm going to separate the board from the heatsink. There is another subboard underneath. You can't really see it here. Here you can. And this is holding transistors. It's got transistor sockets on it. So this is another board. But there's also some, looks like some temperature sensing wires going between the transistor and the main board here. So I might have to be very careful of that. There's all kinds of diodes and stuff sticking up here. And I think they're trying to do some temperature sensing. So I have to make sure I don't break off any of those wires when I separate the 2. It's pretty dirty. I don't know, I might take a bath in the ultrasonic. I don't know, it looks, well, I could probably clean it up. But a lot of these caps are going to, well, all the caps are going to be replaced. These ones look really tired. Okay, remove 5 screws, and yeah, it comes loose, but you have to be careful. See these, some of these are stuck in here. And they're temperature sensors. They're just laying in beside the transistor. And then you can fold this down. Oh my god, look at the glue on this thing. It's gonna need some major cleanup. Huh. Yeah, that's a lot of... This stuff gets conductive and corrosive too, so I wonder... Yeah, it's all corroding underneath this. So I'm going to have to clean it all off, and it's all crusty, so it's coming off easy, but it's damaged the copper foil underneath. It's not even doing anything anymore, it's just crust. So I'll get busy on this. I wonder how I can do this. I can do it like this, I think. If I hold the board like this, I can work on it. I'll put this in my vise and hold it, and then I can work on the capacitors. I'll take some photos first of where everything goes here, because if something comes broken off, these are all single core wires. They're not stranded. So, all right. So I finished cleaning up this amplifier board. Cleaned it, scrubbed it, scraped it. There's all kinds of glue, especially where the glue was. There's corrosion on the board, so I cleaned up the best I could. A lot of the solder joints where the corrosion happened. I resoldered them just to get rid of that corrosion and scraped away. And you got to be very careful of these temperatures. These 4 temperature sensors here, and they got very thin leads, and I broke one already just from manipulating the board a bit. So you got to be watch out for that. If you break any of these leads on these diodes or these temperature sensors, pretty much guarantee you the amp will grenade itself because it loses its bias inputs. So yeah, this has all been cleaned, and I resoldered most of the board. This subboard here for the transistors is really nothing to it. It's just 8 sockets for 8 transistors, and the other side is all new, freshly capped, recapped. No transistors stood out on this one for needing replacement, which is good. So this will all go back together. Yeah, it's all going to go back together. Here's the heatsink and the transistors. I'm thinking this heatsink compound's still pretty good. So I don't see a need for re-gooping that. What I'm going to do is just check some of these screws, see if they go loose. Some of them go loose over time, and they just need to be retorqued. These ones are all a little loose. I'm just going to tighten them all up. And then I'll put this all back together again. We're going to move on to the last piece of the puzzle, is the power supply. So I'm done with this. I'm going to do some more cleaning. I think it's not bad right now, but yeah, I think we could put this all back together. Just check all the connections from underneath. You can see if they get in, and they all do. And then there is a bar that goes under here that locks it in place, this one here. I have to sneak this in from underneath. Try this. Okay. Have to get it over these solder joints. There we go. Okay. So 4 screws here, and that holds the transistor plate in, and then I'll flip this down and put it all together. Alright, so this is a DEC Japan relay type MS4U 24 volts. Looks like it's never been touched before. Actually, first let's test the coil, the contact resistance. You got a power supply here, and let's connect up. Let's connect up, what we got here? We got this here, and this one here. And let's close this one up. Wow, that one's kilo ohms. And that's some pretty bad contact resistance right there. That's 3 kilo ohms. 150. It's pretty poor. Let's check this other one. This one's up around 200-300 ohms. I didn't think it would be that bad. As you work it, it doesn't get any better. So that's pitting and corrosion. Let's do the other side. I wish my leads were longer. Okay. This one's 12 ohms. That's probably the best one so far, eh? 2 ohms. it's not consistent. It's all over the place. Let's try this last one. This one's in the kilo ohms as well. So all these contacts are pretty much, these are done for. So let's open it up and do a full service on this relay. Some of these are tricky to get. Hang on a sec here. I think if I do this, sometimes you got to slip a couple of screwdrivers in just to release the catches, like right here and right here. And then you have a third one. If I can find a third one and just pop it out like that. And out it comes. Give it a little tug. There we go. Wow, the spring took off. Okay, spring's out. Let's have a look. Okay, let's have a look at this. You can see this contact here is really oxidized. These ones actually don't look bad at all. The other three. How about this side? Same thing. So I think this is going to clean up pretty good. I think these are gold plated. Let me see here. Some of these contacts don't look like they haven't even been used. And then the other one beside it is pitted. The pitting comes from the make and break. When you got current when you're making and breaking, it arcs and it flashes over, and the plasma vaporizes the contact material. Either it's gold plating or silver alloy. So yeah, this will clean up nice. I'm just going to use technique I've been using lately, and it seems to be working really well, is just get polish these with like a cotton swab. So let me do that. So what I like to do is, these 4 contacts on top here are just dummies. There's no contact material on them. They're just there to stop the other contacts from going too high up. So I just bend these up a bit just to give us some room to work. Don't go crazy because they'll snap off, and then they'll leave you in a world of hurt looking for a new relay. Just enough so we can get a cotton swab in there. Okay. Now I've never done this on plated contacts before, but I've done it on the silver alloy, and it works really well. So I take a little bit of polish, and this could be any kind of polish really, and what I'm using is a plastic polish, but you can use the brass or whatever polish that you're good with, and just take a little bit on the Q-tip and just polish the ends, and it will remove the oxidation quick. Support them with your fingers so they don't bend. And then you get gunk everywhere. You got to clean that off after. You can't leave that on there. But I can already see, I don't know if you can see that, but you can already see it removed the dark oxidation. Oops. There we go. You see how it removed the oxidation, and you left with a little dot in the center. That's where the pitting is, and that dot. So let's, we're done with that. Let's do the other side. And this one is a little bit worse. I'm going to take this side and clean this off. Okay, let's inspect this again. We got some very fine pitting on a couple of these contacts. This one here is... oh yeah, there it goes. Okay, what I'm going to do is clean this. I'll clean it with a cotton swab with alcohol, and then we'll put it together and we'll retest it. Alright, so let's put this back together. Temporary, like just to test it. Okay. I didn't bend those down yet, but I will. We're just testing this, so let's get our contacts resistance. Okay, and we got 12 milliohms. 10 or 12 milliohms in that one. That one's good. Check the next one. This one's 12 milliohms as well. Good. Let's turn this around. $13. Not too bad. Last one. 13. So they're all good. If we put these two in parallel, we should get even less. We should get 4 milliohms, which is perfect. Can't ask for better than that. So those contacts are clean now. What I'm going to do is I'm going to bend these back down until they are straight again. It's not critical, it's just a stop for the there. That works good. Alright, this one's ready to go back in. How does this go again? This goes like this, according to the end. It's keyed on both ends. There we go. Ready to go back in service. Alright, so the power supply has been recapped, everything's put back together, and it's ready to go back in service. Now, one of the things I find really annoying with this Marantz amplifier is the service manual. The service manual is it's more like a suggestion as to what's going on inside. I find values are different, the board layouts are different, components are different. They have components bodged on the back, where on all the boards have bodges like this, and you know, you can't find, like, here's a 3.3K resistor. I can't find the 3.3K resistor on the schematic. It's almost mind-numbing, because you're trying to work your way through circuits. I'm glad I don't have any faults that I have to diagnose, because man, oh man, it is a mess, that service manual. And I've noticed that on all the boards, that the capacitors, the values, some parts, I see capacitors on the board and I look in the manual to try and find them, and they're not even there. It's like something that was an afterthought. So yeah, that's my thoughts on that. And yeah, but we're getting through it. We're just about done. We got this board done. I got some cleaning to do here, and then we can start reassembly. I got a couple switches to clean, and then we're on the home stretch. We're going to start putting things back together again. Alright, so we're all back together now, and now it's time to do some adjustments. We have our power amplifier installed and connected. Power supply is in, everything's tested good there. Everything else is on and connected. Now we have to do some adjustments. Strangely enough, this amplifier has no bias adjustment. It must be all automatic. They have all these thermistors and temperature sensing diodes on this side of the board that interact with the heatsink. So I think they're doing some kind of automatic trickery there, but these two potentiometers are your DC offset zero balance. And in the owner's manual, it has an adjustment procedure for it. It tells us to connect a voltmeter between pin, what is it, J865 and 860 for one channel, and 865 and 861 for the other channel. And those two points are back at the back side of this board. Now you're gonna have to stick your hand in here and connect a alligator clip, but you also have your 120 volts down here. I don't know if you can see it, but right here is the back of the fuse holder, and I insulated the wire that was coming out the back of that because it was bare, and it's only like half an inch away from the amplifier board. So I cut that wire, put some heat shrink on there to insulate that to make it a little safer. But you still have to get your hand down here to clip on those, so make sure that you unplug your amplifier, and we're going to get in there and clip on our leads. Now 860, where is it? 865 is your ground connection. So I'll turn that on and see if I can get this. There's three wires here, black, green, and blue. They're down at the bottom. Now this comes out of the protect relay. These other two wires, this green and yellow, this is the output signal coming straight off the amplifier board going into the protect relay. But there's really no way to clip onto these two wires. This, and by the way, this white and red wire, that's your positive and negative rails. So let's clip this on. If I can get my hand in here, this is going to be tricky. I don't think I can get my hand down in there. Let me turn the camera off because it's right in my way here. Okay, after a lot of struggling, I did finally connect it to one of the pins there. Put this back on. Put this in frame so we can watch it. Turn on our meter. And let's power it on for the first time. Hope there's no smoke show. We're at 28 watts. And we have no relay click yet. And we still have a trouble with there it clicked. Took a long time. Let's try that again. Yeah, yeah, we almost got half a volt here. Okay, so I'm connected to 860, and we adjust 739, I think. So that's this one here. A better screwdriver than that one. Okay. Sure is twitchy. It's sure jumping around a lot. Turn it down some more. Actually, it's going back up. That's negative. Try and find the 0 point. There, it's twitching between positive and negative numbers, so that is really weird. I've never seen an amplifier be unstable like that. It's only doing maybe 50, 80 millivolts. It's hard to say. This meter is so... Let's see what this looks like. It's jumping all over. Positive, negative. The meter has a hard time ranging this. Okay, let's leave it at that for now. We're at 29 watts. So let's shut this off and I'll move my lead around to the other side and we'll do the other channel. Alrighty, so I'm now connected to J861 down there, and let's turn it on. And it should come out of protect sooner because we don't have half a volt anymore. Still going to take its sweet time. There it goes. Yeah, we got half a volt on this one too. Turn this down to 0. Now they say plus or minus 5 millivolts, but the way it was jumping around there, it didn't. Okay, a little too far. And turn this up some more. Oh, it is negative. Okay, there it is. We're still at 28 watts, or 29 watts. I'm going to hook up a scope. Let's do our power test. I want to hook up a scope and see what's going on with that voltage jumping around like that. That doesn't look normal. I don't think I have any signal going in. Everything's turned off, so there should be no reason for that unless we're getting some hum or something. Okay, let's go a power test. I think I figured out the secret recipe. You just get some masking tape, cut a thin strip, cut 2 thin strips like that, and this, put one on. And then put the second on, and this provides enough grip that the knob doesn't come off very easily. It doesn't come off in normal use. You can pull it off if you have to, but yeah, it's on there. There. It's not going to fall off now. Alright, we're wired in to do a power test, but first I want to look at this this floating DC offset that we have. Let's see if I can get this set up properly. We have system 1, stereo, auxiliary, tone defeat, balance is centered. Okay, turning on. 30 watts. A relay click coming up. There it is. Now, I do have my scope set for DC. Let's turn up the sensitivity of this. 100 millivolts a channel. See, it's twitching around. It is something going on here. Let's 50 millivolts. So we do have a little bit of millivolts of something going on. And I have a feeling that is, let me switch to DC coupled on the amplifiers. It's even worse. So I might still have troubles with problems with the tone amplifier on this. And see how they're both going. If I AC couple it, it kind of isolates that and it lessens. So I think that's coming from the tone amp. Okay, let's do a power test here. Let me reset everything. Alright, so I got 1000 hertz tone. Let's turn it up. It seems like something is wrong here. And we are getting some weird signal on the right channel. That is something I've never seen before. Is that an oscillation? Looks like it's breaking into oscillation. Okay, let's see if that is coming from our power amplifier or okay, if I unplug the right channel, it goes away. I unplug the left channel. It stays. Okay, right channel. Okay, that is the input to the right, let's see here, the right bottom trace is the right channel. That's the input to the power amplifier after all the switching and stuff. And it's clean. No, it's got sparkles in it. That is really weird. Well, we're getting an oscillation on the output for sure, so we need to figure out what is going on with this thing. I'm wondering if we have a dirty power supply. With that DC offset, I wonder if that is a dirty power supply. I unplugged the left channel. It's still there in the right. And it does not like that. If I unplug the right channel, it's gone. You can get full clipping. Okay, let's do full clipping and see what our power output is. Okay, right there, I got 26.04 volts RMS output on the left channel. Let's scope the power supply going to the tone board. I want to see if this is dirty or not. Dirty power going here and causing that fluctuation. So I just need to figure out the right wire here. Okay, so there is 50 millivolts of division. You can see it jumping around. 20 millivolts of division. I have it on AC coupled, so it's not the best response, but it is moving around. So we have a problem in our power supply. Look at the dirty power we're getting. It's fluctuating. Okay. Hi. So this is Future Trevor with a finished amplifier. This is the very end of the saga, but I'm gonna cut the video short here and make this into a two-parter. So sorry about that. It is getting quite long, and I run into a lot of troubles trying to troubleshoot this thing. So yeah, there's problems still going on in this, or was, and I had to take quite a bit of time to fix them. So there's going to be a part 2 to this, so stay tuned for the part 2 next week, and hope you're all well. Take care. We'll see you on the next one. Thanks for watching.